Hi everyone. Today we are going to discuss about computer graphics. Let's see video display devices. The primary output device in a graphic system is a video monitor. The operation of most video monitor is based on the standard cathode-ray tube design. Next, reference cathode-ray tubes. The basic operation of a CRT. A beam of electrons, that is cathode rays, emitted by an electron gun passes through focusing and deflection system that direct the beam toward specified position on the phosphor coated screen. The phosphor then emits a small spot of light at each position conducted by the electron beam. Because the light emitted by the phosphor fades very rapidly, some method is needed for maintaining the screen picture. One way to keep the phosphor glowing is to redraw the picture repeatedly by quickly directing the electron beam back over the same points. This type of display is called a reference CRT. The primary components of an electron gun in a CRT are the heated metal cathode and a control grid. Heat is supplied to the cathode by directing a current through a coil of wire that is called the filament inside the cylindrical cathode structure. This is cathode ray tubes connected with base, focusing system, electron gun, magnetic deflection coil, phosphor coated screen, electron beam. The accelerating voltage can be generated with a positively charged metal coating on the inside of the CRT envelope near the phosphor screen, or on accelerating anode can be used. Sometimes the electron gun is built to contain the accelerating anode and focusing system within the same unit. Intensity of the electron beam is controlled by setting voltage level on the control grid, which is a metal cylinder that fits over the cathode. A high negative voltage applied to the control grid will set up the beam by repelling electrons and stopping them from passing through the small hole at the end of the control grid structure. A smaller negative voltage on the control grid simply decreases the number of electrons passing through. Since the amount of light emitted by the phosphor coating depends on the number of electrons striking the screen, we control the brightness of a display by varying the voltage on the control grid. We specify the intensity level for individual screen position with a graphics software commands. Focusing is accomplished with either electric or magnetic fields. Electrostatic focusing is commonly used in television and computer graphics monitor. With electrostatic focusing, the electron beam passes through a positively charged metal cylinder that forms an electrostatic lens. The action of the electrostatic lens focuses the electron beam at the center of the screen in exactly the same way that an optical lens focuses a beam of light at a particular focal distance. Similar lens focusing effects can be accomplished with a magnetic field set up by a coil mounted around the outside of the CRT envelope. Magnetic lens focusing produces the smallest spot size on the screen and is used in special purpose devices. Additional focusing hardware is used in high precision system to keep the beam in focus at all screen position. Therefore, the electron beam will be focused properly only at the center of the screen. As the beam moves to the outer edge of the screen, displayed images become blurred. To compensate for this, The system can adjust the focusing according to the screen position of the beam. As with the focusing, deflection of the electron beam can be controlled either with the electric field or with a magnetic field. Cathode-ray tubes are now commonly constructed with magnetic deflection coils mounted on the outside of the CRT. Two pair of coils are used, with the coil in each pair mounted on opposite side of the neck of the CRT envelope. One pair is mounted on the top and bottom of the neck, and other pair is mounted on opposite side of the neck. Horizontal deflection is accomplished with one pair of coils and vertical deflection by the other pair. The proper deflection amounts are attained by adjusting the current through the coils. When electrostatic deflection is used, two pair of parallel plates are mounted inside the CRT envelope. Different kind of phosphor are available for use in a CRT. Besides color, a major difference between phosphor in their persistency. How long they continue to emit light after the CRT beam is removed. Persistence is defined as the time it takes the emitted light from the screen to decay to 1/10 of its original intensity. Lower persistence phosphor is required. Higher refresh rates to maintain a picture on the screen without flicker. A phosphor with a low persistence is useful for animation. A high persistence phosphor is useful for displaying highly complex static pictures. The maximum number of points that can be displayed without overlap on a CRT is referred to as the resolution. Thus, resolution of a CRT is dependent on the type of phosphor, the intensity to be displayed, and the focusing and deflection system. Difficult. Resolution on high quality system is 1280 by 1024 with a high resolution available on many systems. High resolution system are often referred to as high definition system. Another property of video monitor is aspect ratio. This number gives the ratio of vertical points to horizontal points necessary to produce equal length lines in both directions on the screen. Sometimes aspect ratio is stated in terms of the ratio of horizontal to vertical points. And aspect ratio of 3/4 means that a vertical line plotted with 3 points has the same length as a horizontal line plotted with 4 points. Thank you.